Hello everyone, this is Jay for the Nuke Junkie YouTube channel, and today I'm going to present to you the long-awaited part 2 of my two-part assembly uh, series. I won't call it, I guess series is a long word. It's only going to be 2 parts. Maybe we'll do some more assembly stuff after this, but I want to finish up the second part of this. I know it's been a long time since I've gotten back to this, and sorry for that, for those of you who've been waiting, but here it is. So, what we're going to do today is we're going to continue on from the part 1. We're going to talk about the bat file that I use to create the executable bin files for the Color Computer emulator inside of MAME. I'm going to show you how that gets compiled, or I should say assembled, and then we'll watch it run in MAME, and then we'll do some other neat stuff in MAME just to kind of show you how that works as well. So as I said in part 1, this is more of a tools presentation than necessarily an assembly presentation. And I'm going to stick with that theme in part 2 here. So as you can see, we have Notepad++ open. There's 3 files available in it. The first one of interest to us is asem.bat. I'm going to go through this file line by line and tell you what it does so that you understand it. You guys can use this file if you'd like by typing it out into a Word document like this. Just name it .bat when you save it and not .txt, and it should work fine for you. Also be aware that this file needs to run from within the directory where your .asm file that you want to assemble resides. Also in that file folder, you have to have all the LWASM tools, the image tool program in that file folder as well. So what we're going to see here, we have first line's echo off. Essentially, that tells it not to echo all these commands to the screen in the command prompt when you're running the batch file. For those of you that aren't aware of how a batch file works or how you make it run, I'm going to show you that here in a little bit. Then we have a CLS command. It's simply clear screen, so it clears the screen so that there's no garbage left, so you can see exactly what's happening for your program that time. The next line is LWASM. That's calling the program for LWASM to assemble. %1.asm. The %1 is the first command line parameter that you feed to the asem.bat program inside of the command prompt, and I'll show you that when we get there. But %1 essentially is the name of your assembly file that you want to assemble without the .asm extension. Then we have couple parameters that we are feeding to LWASM to tell it how we want it to assemble our program. The 6809 option tells it to assemble for 6809. So doing that means it will not accept 6309 codes. We're telling it to create a listing, and we're telling it to also list out the symbols that are within the file. 6800 compatibility, that essentially allows us to use 6800 commands, and they get translated by the assembler into the appropriate 6809 assembly commands, and that's simply just because it makes certain things easier and shorter to use when you are writing the assembly code. Then we have a map, map.txt, that essentially shows us a mapping of the different areas of memory that are being used and what's using them, and we'll look at that as well. Next thing is output equals %1.bin, so that's telling LW assembler that the output files should be named the same thing as the input file with .bin as the extension. Next parameter is format equals %2, so LWASM needs to have a format that it knows it needs to compile to, assemble to, and that's going to be the second command line parameter. And then the caret and then listing.txt basically tells it to send it the output to listing.txt with versus the screen. It would normally default to sending to the screen, but we're having it go into a file instead. The next line says if error level is not equal to 0, then go to end of file. That's what EOF is for, end of file. So this is basically saying if the LWSM command above it doesn't execute correctly, it will give us an error level code of something other than 0. And if that were to happen, it'll go to the end of the file and essentially would not try to continue on through, and then you'd have to figure out why it is not continuing. Next line is image tool. That is the image tool that I had shown earlier. Essentially, image tool allows you to make images, allows you to delete images out, put new images into a file, into a disk image, that sort of thing. So the first line, what it does is it's going to delete a disk of the file, a disk of the type coco_jvc_rs DOS, which is what our file type is, disk file type is. Tells it where that disk is, so you can see, excuse me, you can see there the path to the 180KRS disk, then %1.bin, so that's telling it to delete the program that we gave it as %1.bin. If the file does not exist, it will give you an error saying file doesn't exist. However, that error does not prevent execution because there's no error level statement below it, so it will just continue on to the next file, or I'm sorry, to the next line, which is what you want, because if the file doesn't exist for the first time that you're executing the program, you don't want this batch file to crash just because it doesn't exist when you know that it's not going to exist. Then upon subsequent executions of this file, it will delete it and write a new one. And it's not really necessary to do that. It will overwrite it, but I like to be clean and delete it and then put the new file in its place. Next thing you'll see is image tool. It's going to say you're going to put the same again. You got your file type coco_jvc_rs DOS. Same path. Tells it where the disk is that it's supposed to write to. Then it's telling it to put %.bin, which is the file that we created, onto the disk as %.bin. So you can specify a different name for the file on the disk if you want to, and that's useful if say your file name that you're using on Windows is long or uses some characters that the Coco doesn't allow in its character or in its disk format. So you could rename it to something that would be Coco friendly. In this case, I'm just careful to make sure that my file names fit, what the Coco needs. So I use it as %1, so it's the same for both. Then we have an error level statement again. So if for some reason it cannot write the file to that disk with the appropriate parameters of appropriate file names, it will give an error and go to the end of file. If not, it continues on. It changes directory to my MAME-UI directory, which is where I run MAME out of. Next line is the execution for MAME. Now, if you download just MAME, you'll have a MAME64.exe. I have MAME-UI 64, which is a Windows specific program that allows some GUI goodies for using MAME. But either way, it's essentially the same command whether you're using MAME-UI or you're using MAME. So anyway, that comes through. It tells Coco 3, which tells it what type of computer that you want to start up for emulation. No filter command, which I honestly at this moment don't remember what that does, but it's I always include it. I have to go look and see what that does, to be honest with you. The debug, which basically tells it to open up a debug window when you start MAME. Natural tells it to use a natural keyboard, which allows the PC keyboard to be more closely mapped to the characters for a Coco keyboard, so you don't have to try to remember the differences between the keyboards. No mouse, no joy basically tells it, hey, we don't have a mouse or a joystick, so it's going to emulate those with keyboard input when it can. Skip game info, it basically tells it When MAME starts up, there's a window that comes up that kind of gives you a small synopsis of the machine that you're starting, and that essentially just has it skip that information. Window tells it to put it into a window. That way it does not hog up your entire screen. Menu tells it to include the drop-down menu in the window for pulling other functions. Otherwise, at least in a Windows environment, it makes it a lot easier to find and change your setup within MAME without having to get into the actual MAME menuing system, which I find a little cumbersome. So, excuse me. Then the next thing is flop 1. That tells it that we want to load something into floppy drive 1, and then we tell it where the disk is that we want to load, which is the same location we used to where we put the disk in the first place. Then the last line, all that is doing is simply changing my directory back to the directory where all the programs are, so that we can then continue to run this program again without having to do a lot of manipulation. So you may be wondering why I go through writing this batch file. What does it do for us? And the point of having the batch file is to speed up your turnaround time for compiling code and testing it. So what this file does for us essentially is it assembles the assembly file that we want to execute. It puts it onto a disk for us. It starts that disk up in MAME, and then when we are done with MAME, it puts us back into the directory so we can do that whole process again. So that allows us to have the assembly file open in Notepad++ or whatever editor you might want to be using, make changes to it, save it, then you go back to your command prompt window, rerun the assemble.bat batch file, and it puts you right back into MAME without having to type bunches of all these commands pretty much individually to do that. So it's the idea of a batch file, and that's why I use it, and the benefits of using that batch file. Now there's other batch files that you can create. I have a batch file that I'm not going to show because it doesn't really have anything to do with what I'm presenting here. But I have a batch file where I can also pull files off of the disk after I shut down MAME to use that file for other purposes. So, but this is the main batch file that you want to have to do what we're going to do. So what I'm going to show you next is this is the command prompt window. You can see it has a file here, letters.bin. That is the file that we are going to be assembling today as our example file. And then down here is just the file folder for the different stuff. So what I'm going to do while I'm in the file folder here is I want to show you guys. Sorry, I got to get this open for myself here. What I want to show you guys is I want to go in here. I'm going to take this listing. I'm going to delete the listing file here. And I didn't delete it. I highlighted it. Delete listing. I'm going to delete letters.bin. And what was our other one? Oh, map, right? Map.txt. So there's map.txt. And we'll delete that as well. So that's all the files that the batch file is supposed to create for us. So we will run the program and verify that happens, and we'll take a look at those files as well. So let's go back to scene 1. And I'm going to do is I'm going to get rid of listing.txt. Yep. So we deleted it, so it tells us that it doesn't exist anymore. So we're going to get rid of that for now so we can look at it. Alright, so this is the second tab here. There we go. So second tab here is letters.asm. That's the assembly file that we're going to assemble. So I'm going to go through here real quick and tell you what it does. Bear in mind that this, like I said, this is not an assembly tutorial. I'm not trying to teach you assembly. but we will go through here rather quickly, and I'll just kind of give you the flow of what this is supposed to do. So org 4000 is basically telling the computer that we want it to start putting this program into memory at address 4000 hex. Then this first here start is a label. It's basically just for humans. Computer doesn't care about it. It gets eliminated. Doesn't go into the code in any way, but it's just a way for us to use more human type words to make more sense to us. Then we have PSHS, that is push S, so it's pushing to the stack. If you remember from my first tutorial, S was a 16-bit stack, and that the processor uses to store things and to get things back off of at a later time. So it's pushing X and then A onto the S stack. Then LDX is load X. It's going to load X with the value of 0, the immediate value. The number sign means immediate value, and the dollar sign means hex, so hex 0, although hex 0 and decimal 0 are the same. Then we're going to do an LDA, which is load A. That is the immediate value 65. 65, since there's no dollar sign, it's going to see that as decimal, so that's a decimal 65. Reason we're using 65 is because in Cocoa terms, the value 65, if you push that into memory in its text window, which is what we're going to be doing, it interprets that as the letter A. Next thing we have is another label loop. That's going to have us store A. So we're taking this value that we put in A, 65, and we're going to store it at 400, X. So that's saying store A. We're going to take whatever was in A, and we're going to put it at 400, X. We loaded X with 0, so it's going to 0, 400 hex. We're going to compare X with the decimal value 511. Reason we do that is because there's 512 characters on a letter screen, and so we go from 0 to 511 is 512 locations. We do a branch if equal to loop 2, BEQ, branch if equal. That's essentially saying when the processor does the comp X command, if it is equal to 511, it will set the appropriate flag register to 0, and if it does that, then it will jump to loop 2. If not, it will increase X and jump back to loop. When it increases X, now we come in here, now we're storing A again to 400, X, so that would be 40401, because we incremented to 1, so now we're putting the same value that we had in 400 into 401. We continue on, do the comparison again, and continue through, and essentially what this will do is it's going to put the same character in 512 memory locations from 0400 to 0400 plus 512 in decimal. When it's done with that, it will come out of this comparison with a 0. That will jump us to loop 2. Loop 2 is going to increment A, which will make A go from 65 to 66. We will load X back with 0, which is essentially resetting that counter. We'll compare A to 91, which means that the A will increment up every time through this loop until it equals the value of 91 in decimal. We'll branch if it is equal to the end label. If not, it will continue and it will jump back to loop. When it jumps back to loop, that is going to go through. It's going to print the symbol for 66 from 0400 hex to 512 characters beyond that, or memory locations beyond that, with the character 66, which in Cocoa World is a B. It will continue to do that until A equals 91 here, which 91 is the Z, and if you do the math, you can see 65 plus 26 is 91, 26 characters in the alphabet, so that's where you come up with 91. When that comparison is good, it will give us a 0, jump us to the end. When we get there, we'll do a PUL, excuse me, do a PULS, A, comma, X. So we're pulling the registers back off the stack in the reverse order we put them on, which is the way the stack works. Then we do an RTS, which is return to subroutine, which in this case, since we are in the only subroutine that was started, that will dump us back into basic. And then we have our end statement, and it's just end start is just to marks the end of the piece that started up here with start. So that's what the code's doing. And what we'll do now is we will go to, let's see here. So this is our command prompt. What I want to do, I need to, give me a second here. Close that out. All right, so now we're back into our command prompt. It's in the folder that I want it. And what I'm going to do here is I'm going to issue the command to assemble our program. So we got ASSEM, oops, excuse me, EM. So that's the name of the file, the bat file. Now we're going to give it the name of the program ASM that we want without the extension, so it's just letters. And then the last parameter for the format is DECB, which stands for Disextended Color Basic, which is the format we want for the file so we can run it on a Cocoa. And when I hit enter, a lot of stuff happened behind the scenes. And we are now, you see the putting files letter.bin ... Now, if we come down into the file area down here, you'll see you got letters. Here, it also made letters.bin, which is our bin file executable. It also gave us our listing file again, and it also gave a map file. So what we'll do here is we'll go in and we'll look at our listing file in Notepad. Go into listing. So what this listing file is showing you is essentially what happened when the assembler assembled your program. So you can see over here on the right hand side, you see essentially our code that we started with in the program, in the text file that we looked at. Over here, these are memory locations. You can see 4000. We told it org 4000, so it started at 4000. You can see that at 4000 start was here, and it did not get encoded to anything, so it used the same memory address in the next line. Then it did a 3412 in hex, which is the hex representation of PSHSX, A command. And it continues on through, counting it down through memory locations as it executes, or as it puts commands into memory locations. And then we got 402239, which is the RTS command. So 4022 is the last memory location that will have any information for our program. At the bottom, it gives us the symbol table. If you remember, I told it one of the parameters we gave LWASM was symbol. So it created a symbol table, and what that basically tells us where our symbols or labels exist. It will also tell you things if you have variables that you create and such inside a program, which we didn't do in this particular program, but you could do, and it will tell you where those items are defined, what line they are defined on. So you can see here, for example, 4007 is loop. If we go to 4007 and we go over, we can see that in fact that is where loop starts. So that's what our listing file does for us. If we go back and we open up our map file, we can see the same deal. Essentially, it tells us the same thing as our symbol information. Tells us what file it created them from and what memory location they exist in. This would be not so useful here, but if you're doing multiple assembly files in the same assembling operation, you would have multiple symbols with multiple different assembly files that it came from. So that's what we're doing there. So we go back to here. We talked about our map file. We talked about our listing file. We talked about our letters.bin file and letters. And I believe that's everything that it created for us. Yes, it is. All right, so now what we can do is we can look at the MAME, excuse me, MAME window. I'm just trying to get us set up here with the debugger as well. Unfortunately, whenever MAME resets, then I have to go in and recapture the windows, so it makes it a little cumbersome, but you'll just have to bear with me there. And I'll make this a little bigger so you can see what's going on. And this guy will move over as well. Alright, so this window here is the window. It's black right now because the debug window is opened and it started on beginning of execution, so it is waiting for a command to execute. So if I hit F5, that will cause the debugger to execute, and since we don't have any commands that we gave to the debugger yet to do breaks or any kind of stops, it will run the program through to the end. So we come in, it starts up the Cocoa itself into its basic operating system, and then what we'll do here is we'll load the file from the disk that was already put into place for us. We want to load letters because that's what we called it. See OK, and then I'll do exec, which is telling it to execute that program that's in memory now. And you can see that it ends with all Z's on the screen. Now, you might be asking, well, what happened? What happened with A through Y? And the answer is that it's so fast that you can't really see it occur. So, what we're going to do is we are going to go and we're going to clear the screen. And what I'm going to do is I'm going to go up here into the debugger, and we're going to do a line by line check of what's going on. So what I'm going to do is I'm going to tell it to create a breakpoint at 4,000. So it's set. So now, if I where the heck's that option at? There it is. Let's try soft reset. Okay. Maybe not. Let's try a hard reset. Yeah, that's what I thought would happen. All right. Give me a second. Let me get this set up for you guys again. All right, there it is. So I'm going to put my breakpoint in here again for memory location 4000. And then what we're going to do is we're going to execute. Let it start up. Go with load M. Oops, sorry, I got to cursor over to the other program. Load M, letters. Now when I execute this time, it should stop us. If you watch in this window down here, right now we're at A7D3-ish. When I hit enter, that should take us to 4,000. You can see 4,000 is our, if we go back and look at our letters.asm, our first command is pshsxa, x comma a, excuse me. And you can see that is the command that it's showing at 4,000. So that is our program. So what we're going to do is we're going to step through here and we'll see what it does as it executes. The other thing I want to show you guys is I'm going to go into I'm going to go into the debugger and I'm going to start up a memory window. And then I'm going to add that memory window to our display here. And there she is. And we'll put that here and drag it down just a little bit bigger so that it's nice to see. Oh, I can't do that there. Give me a second. There we go. Alright, and then we're going to go here. What I'm going to do is I'm going to tell it to go and put 400 at the beginning of the memory map that it's showing us. And if you look, you'll see 0400 says disk extended color basic. Well, our screen for the Coco, disk extended color basic. So essentially 0400 starts our text memory for the text display window. So in this case 44 is giving us the character of D. So what we're going to do is we're going to look at I just got to get my windows arranged here. So we got memory, we got our debug, and we got that. Alright, so what we'll do is we'll go down here, and as you can see we have for debug, actually it doesn't show you guys the menu, sorry about that, I forgot, it doesn't do that. But what we're going to do is we're going to essentially what we're going to do is we're going to step through the program, and I'm going to go line by line to basically show you how it executes. So we got push XA. So we'll do an F11. If you watch the S register on your screen, it's going to change because we're adding codes, values to it. And it did. So now we're going to load X with 000. X currently is ABAB. When we execute this command, it makes it a 0. We're going to load A with 41. Right now A is 00. So we're going to load 41 into it. You can see D changed to 4144 because the first half of D is A. We're going to store A at 0400, X. So if you watch the memory window, it changed to 41, which is what we set A to. Excuse me. Oh, just so we're clear, in the program, if we look here, give me a second, I gotta find my cursor, there it is. If we go back to here, you can see LDA, we told it 65. Well, the computer only knows hex, so it converts, even though we gave it a decimal number here, which is easier for us to understand in the program, it will convert it to hex because that's all the computer understands. So 65 in decimal is 41 in hex, and that's why we're seeing 41 in the main debugger. Then we're going to do a comparison to 01FF, which is 511 in hex. It's not going to see if we look at when we hit the you can see in the flags here, the Z flag is not lit up, which is what we would need in order for this BEQ not to execute. I'll hit F11. Oops, excuse me, I gotta click back on here. Hit F11. You can see that flag's changed, but we got the N, which is not 0. So the BEQ is not going to execute. We're going to continue on to 10. We're going to do an LEAX. LEAX 1, X. So if you remember when I told you we allowed 6800 compatible opcodes in the BAT file when we initialized LWASM, so that allowed me to use the INC Inc A opcode, which is not a 6809 opcode. It's actually a 6800 opcode. But since we had that compatibility turned on, it automatically took the Inc A command and converted it into an LEAX command for us. And that's just, for me, is more user friendly. So that's why I do it that way. So it's going to increment increment X. So we should see X turn to 1 here, and it did. It's going to jump to 4007, which is going to put us back up. And now it's going to store A at 0400, X. X is 1, so 0400, 04 01 should now change to 41 if you watch the memory map. And it did. It's going to do comparison. It's still not equal to 0. And we will continue on. It's going to increment X again and jump back up. So what we're going to do here is we're going to let this thing chug along for a bit, changing this into 41s as you can see, and it is drawing A's in the memory window, like so. Now it's not updating in the it's not updating on the main window because of the way the emulation works, but you can see that it is updating in the memory window as well. So we're going to continue on here, and X is counting along. And when we get to X being equal to 1 FE, we'll stop, and I'll show you the change, how it changes from A to B, and then starts drawing B's. So we're continuing along. Now we're at 010 F-ish for X, and we'll continue to let this chug along until we get into 01F territory. If you watch, you see the X there counting up one by one as it goes through the iterations. Oh, and I missed it. Let me see here. So, or did I? 014. Oh, maybe not. Oh, no, I did. Whew, thought I missed it. All right. 01F we need. So we're at 6, 7, 8, 9, A, B, C, D, E, and we'll get to F here. All right, and then we're going to page through 9, 10, well, D, and it's E. All right, now, if we scroll down here in the memory box, we'll see right now that we have 2 to go. So the 05 FF location is the last location in the window for the text memory. So right now we're ready. We are at the point right now where we are going to fill the 01 FE location. So let's go ahead and do that. You store it. We increment here. You go back up. We store it again. So now you can see the entire text page to 05 FF is all 41s, is all A's, as shown over in the text portion over here. Now, when I hit F11 to continue, it's going to do that comparison. And now, as you can see, X is 01FF, so that comparison will come up true. We should see the Z flag come up here for 0. So let's do that. There it is. So now it's going to test if it's equal to 0, which the flag for Z is. So it's going to take the jump to the 4015 memory location. You can see there 4015 gives us the Inc A. The Inc A, excuse me, my thing here. Yeah, I'm sorry, that was Inc X I was talking about earlier that it changed LEAX into. Sorry about that. It doesn't Inc A, so we should see when we click here 41 A41 will change to 42, and it did. We'll reload X with 0 so we can start the count again. Now we're comparing A to 5B, which is the hex number for Z. It doesn't equal it, so 401B will not execute, and it will jump us back up to the top for 4007. And if I scroll the window back up here to 400, we'll see here 400. When I execute this, it will put a 42 there. And then if we continue on, you can see that now the text screen over on the right hand side of the memory window is filling with B's, and that is that will continue through until it is all B's. It will increment an A again to the C value, reset X to 0, jump back up, and continue on and on and on. Now eventually, and I'm not going to make everybody suffer through stepping through all these, eventually it's going to come down here to this 4019 line. It's going to compare A to 5B hex. It's going to equal that because that's Z. When it does, it's going to hit this branch if equal. It will be equal. So it will jump to 4020. 4020 is the pulls SAX, which is going to pull the A and X registers back off the stack. Then it will do a return to subroutine, which will return it back to basic. So what I'm going to do here, if I can remember which command it is, I think it's, I want to say F10. Let's try that. Or no, I'm sorry, it's going to be F5. So I'm just going to do F5. And now you can see, since it's back out of single step mode, the Z's updated on the screen. And you can also see in the memory window that all the values for the text screen memory have been changed to Z's. So that's how you can use the MAME emulator along with its debugger to step through a program to see what it's doing, how it's doing it, and then also using memory windows to see what values it may be either taking out of or putting into memory. So that is, I believe, everything I want to show you guys in this video. So what we covered, just to recap, we covered, excuse me, gotta find my cursor here. So we covered the assembly.bat file, what it does, how it does it. We went through real quick explanation of what the letters.asm file is going to tell the computer to do and how it's going to tell it to do it. We assembled the file, and we looked at our listing file, which shows us the output from the assembler and the information that's available there, and the map.txt file, which in this instance is pretty much the same as the symbol table on the listing, but in other situations would be somewhat more complex. Then we moved into looking at the command prompt and how we enter the values into the command to get it to execute our batch file properly. Excuse me. Then we moved to the main debugger, and we execute the program, step through it step by step to show how the registers change, how the computer increments in order to count, and how we can make it make decisions to hit different branches and make logic decisions as far as how it needs to proceed in the program. So that's all I have. If you guys enjoyed the video, please like and subscribe, and leave me some comments. Let me know what you'd like to see next. We could I'm thinking either get into a maybe an assembly discussion and how to do those things in MAME, possibly into a more in-depth assembly program, maybe do some very basic graphics to show you how that works. So give me some comments, let me know what you'd like to see. I will promise that if you guys leave comments and let me know what you want to see, that I will make videos more often to accommodate those requests. If I don't get requests, then I probably won't make the videos nearly as often as I might otherwise. I do know it's been a long time since this video came out, and I'm sorry about that, but just didn't get around to it because of many other things. But I would like to make a few more videos on this topic if you guys let me know what you'd like to see. Alright, so thanks, and I will talk to you guys in the next video.